Alright guys, so what we said is y is equal to 7 to the power of x in this question, and we got to find dx dy. This means we need x in terms of y, so we ln both sides. Then we did the power rule to take the x to the front, and we're left with ln x equals ln 7. Now, sorry, x ln 7. Bring the ln 7 beneath the ln y, and what you're going to get is x equals ln y over ln 7. Now, it doesn't specify in the question in terms of x, does it? It doesn't specify that, so you don't need to worry about it. Now, the difference between dy dx and dx dy is as simple as what, lads? Simple as flipping the fraction upside down. If dy dx was 2 over 3, dx dy would be 3 over 2. So we're using this logic on the last question. So, okay. So we actually still haven't found dx dy yet, have we? We've only found out what? X is, haven't we? So what we're going to do next? X equals ln y, and then I'll just put 1 over ln 7 here. What happens when you differentiate ln y with respect to y? What do we get? 1 over y ln 7. You cool with that? Now what happens next when we turn it upside down? Huh? So turn it upside down and we get y ln 7. Now the description of the question says it wants it in terms of x, so what should we do then? Replace y with 7 to the power of x. So 7 to the power of x ln 7, is that alright? We all cool with that? Okay, cool. Now, next thing it's going to ask me is show that the integral, so I'll bring this down with me. Show that the integral of 7 dx, 7x dx is 7 to the power of x ln 7 plus c. Alright? So show this here. Now, okay, ready for this? Now, here's what we're going to do. We're going to bring over the dx over the other side, so we're going to get dy equals 7 to the power of x ln 7 dx. Then you integrate both sides. When you integrate dy, what does it turn into? Y. It's like integrating 1 to y, it turns into the y. You integrate the other sides. Okay? And when you integrate the other sides, what you get when you do... we already figured this out earlier. We've already gotten 7 to the power of x ln y, haven't we? Sorry, 7 to the power of x ln 7. So what happens when we integrate that? What do you get? Oh God. Now if you look at the answer we're looking for 7 to the power of x dx on its own, aren't we? Does that make sense? So we're looking for 7 to the power of x dx on its own. That's what we're looking for on its own. So I was actually looking at the left side when I should have been looking at the right side. Does everybody see the 7x dx here? Yeah. Now, even before I integrated, what I should have done maybe just before I integrated was this. Divide both sides by ln 7. And what happens then? What happens if I divide both sides by ln 7? Yeah, I get 1 over ln 7 to y, and then I get 7 to the x dx on its own on the right hand side. Is that okay? Now, what we're going to do now is we're going to integrate. Now, essentially, this part here is a constant. How do I know it's a constant? It's just a regular number, isn't it? So, if I asked you to integrate 3y, if I asked you to integrate 3, what would the answer be? It was with respect to y, it'd be 3y. With respect to x, it would be exactly, right? So that means it's going to be 1 over ln 7 times y. Now we can't integrate that, that's the point of the question. But what is y? It says at the start 7 to the power of x. So what can I change the y into? And that proves what they're looking for, isn't it? And then just plus the c and you're done. For tonight, lads, you do me a favour? I want you to go through this process again, except with one exception. Everywhere you see a 7, just lob in a 5. And see if you're able to get the answer out, okay? Just do that one more time. Alright guys, let's keep going. What's the next question you'd like me to do? Now, we've done 11 and now we're going to do question 9. Now here's what I'm going to do. I'm going to break this up into e to the x plus 2 over e to the x plus 3 over e to the x. Integrate all that with respect to dx. We're all good? Okay. Now, what we're going to get is, you take away the powers, don't you? If I had x7 over x3, what would the answer be? x4. So take away the two powers. What's x plus 2 take away x? Plus e2, is it? And what about this one here? The negative power, isn't it? Have we integrated yet? No. Okay. E2 is a regular number. It's like 3. So what would be the answer when you integrate it? E2, e squared x. What about this one here? Keep the power. Keep the power. And differentiate the power. And you get minus 1. What's 3 divided by minus 1? Exactly. And there's a... Are we cool with that? Yes? Oh, if you were asked to integrate 3, what would the answer be? So e squared is just a regular number. If there's no x in the power position, it just behaves like a regular number. We all good? Alright, let's... Yes?
So you can only integrate the x if it's only a number. So powers 2.
If it's only a number like e to the power 4, that's just like 5. It behaves the same.
But if it was e to the power 4x,
Then it'd have to be e to the 4x divided by 4. Okay, good cut. Alright, that was 9. Now we're on 10. Where to put 10? 9, 11, 9, 10. Alright, this one here. I'm going to square this out. So what you got here? EX by EX. Alright, let's try this again. What's x to the power 2 multiplied by x power 2? That's a bad example. What's x power 2 by x power 3? You add them, you don't multiply them. So what's ex by ex? Exactly. Add them, don't multiply them. Who multiplied them? Alright, at least there's honesty. Now ex by e to the minus x? Minus e0, right? And then this one, same thing. And the last one, e to the minus. Alright, the two e0s are 1 each, aren't they? So does anybody get e to the 2x minus 2 minus e to the minus 2x, like so? Have I even integrated yet? Haven't even integrated yet. Okay, what happens now? Yes?
Would it be positive e to the minus 2x?
Yes, it is. Thank you, Michael. Got one back. Alright, good man. So, thank you. That is a positive e to the minus 2x. Okay, because 2 minuses make a plus. Now we're going to integrate. So, it's going to be e to the 2x divided by the derivative of the power, which is 2. Add an x onto the constant. Same deal here. Keep it. But then what you got to do underneath?
minus 2.
And minus 2 is the same thing as minus a half, isn't it? So 1 over minus 2 is the same thing as minus a half. So I'll just do it as minus a half. Plus c. Who keeps forgetting the plus c's? Yeah, it's always somebody. Right, we all good? It's worth 3 marks. It's terrible you get it all right and you just forget the c at the end. Alright, shall we move on? Alright, 9, 10, 11. I think I'm off to 13 now. Nope. 10, 13. Okay, here's a curve. K is a constant and it has a tangent. So it's an exponential curve. It might be going this. Oh, sorry. It might be going this way. It might be going that way. I don't know. But what I do know is that it has a tangent at the point 1 and e squared. This means there's a slope that will only hit the graph once. Sorry, that's not what I was looking for. So there's a slope that will only hit the graph once, like that, something like that. Okay, we cool? So, in differentiation, the first derivative is the slope, isn't it? So, this is not the original curve, this is just the derivative of the original curve. So what we're going to say here is the first derivative equals the slope. So the slope and passes through the origin. Perfect. So what else do we know?
0, 0.
So what can you tell me about the slope of this graph?
E squared.
Yeah.
E squared minus 0 over 1 minus 0.
1 across and e squared up. You could also use the slope formula, couldn't you? Right. Make sure the old masks are on if we can, lads. Thank you. Look, I'll just do the slope formula. Yes?
If you use the slope formula there, how do you decide which one is y2 or which one is?
It doesn't matter ever. Once one of them's x1, y1, the other one's x2, y2,
Yeah.
it's interchangeable and you'll always get the same answer. So that's good news for us. Anybody get a slope of e squared?
Yeah.
Excellent. This means the first derivative must be equal to
E squared.
e squared. What's the x value for the first derivative?
1.
1. See the 1 there? Means 1. E to the k times 1 equals e squared. This means k equals 2. Is that alright? K equals 2. We already found the gradient of the slope, didn't we? What is the gradient of the tangent? What's the slope of the tangent? E squared. What's the value of k? K equals 2. What chapter are we in currently? Have we integrated at all yet? I've done 0 integration. What does that mean?
We're going to have to look for the equation.
Means I'm probably going to do it now for the equation of the curve. So the equation of the curve is e to the, so the derivative of the equation is e to the 2x. Once again, you do your little dy equals e to the 2x dx. You integrate both sides. What happens when you integrate 1 dy? Turns into y. It was 1 dx, it'll turn into x. It was 2 dx, it'll turn into 2x. It was 2 dy, it'll turn into 2y. Now what about this one here?
E squared 32.
Divided by the derivative? Plus c. Now, we should be able to find the c value, shouldn't we? How do you find the c value? Sorry, Brian, you see a mistake?
No.
What is it?
I don't understand where you got the dy on the integrated dy.
Here?
Yeah.
What's the integral of 1 dx? 1x. What's the integral of 5 dx? 5. So likewise, what's the integral of 1 dy? Y. You integrate both sides. If you integrate the right hand side, you have to integrate the left hand side. Is that alright? So, see the way what I did here, Brian, was the dx, I brought it upwards, like so. And now what I had on one side was dy, and what I have on the other side is dx. And to turn dy into y, I need to integrate both sides. So that's why I integrate the left side and integrate the right side. Okay? And now I have to find the c value. Any of these have to find the c value? What point do we know on the curve? 1 and 1 and e squared, isn't it? So the y value is e squared when the x value is 1. That's interesting. What does that make c then? Bring the e squared minus 2 over the other side. One of them, take away a half of them, will equal what? And we get e squared over 2 for c. Therefore, the original function must be y is equal to e to the 2x over 2 plus e squared over 2. Would anybody know a fancy way of arranging that? Actually, there isn't one, really. Not really, just leave it. Alright, Barry, you have the question?
So I was wondering like, what happens to dx down the
Alright. I've got to differentiate the first derivative. There's two parts, the red part and the green part. So the first derivative, or f dash x, is, alright, let's call the red one u and the other one v. Okay, so u times dv dx plus v times du dx. Okay, so u is 2x. What's the v dx, lads? What happens when you integrate e to the x? Or sorry, when you differentiate e to the x? Exactly. V is e to the x. And what happens when you differentiate 2x? 2. Everybody cool with that? Okay. What does it want from me now? Hence find this function here. Is that cool, you guys? Now see the way I sort of changed it out for a y for a minute? So what's my next step, do you reckon? Cross multiply, and what do I get? 2x e to the x plus 2e to the x and dx. Is that okay? Now some of you might have missed this part yesterday. Do you remember we integrated 3x plus 5 earlier? Does everybody remember that? And we all found it easy. But this actually means integral of 3x dx plus integral of, see the way I can split the integral into two different parts and it's the same answer, isn't it? Was it 3 over 2x squared plus 5x? Same answer, isn't it? So what do you think I'm going to do down here? When I do this, what's the next step after that then? We all know that's y. That's no brainer. What about after that? See the way we split it up? If you reread the question, what's the target of the question? So the target of the question is to get this part on its own. So I want the green part on its own and I want everything else on the other side. So what can I do next then? Y minus what? Alright, and what's y? What is y? 2x. Exactly. Now, what's the integral of 2e to the x? That's what we're on now. What is it? 2e to the x, no worries. What about the power? Just 1, isn't it? So, nothing to worry about, and just add on it. And that's our answer. Who got that one? Alright. We good? Alright. Now, 15 and 17, right? Where are they? Sorry, last time we say 15 and 17? Ah, there we are. Alright, happy days. Very similar to the last one. Okay? So we're just going to say, we're going to do f dash x. We're going to say u is x and phi is sine x. And we're going to do u dv dx plus phi du dx. And we're going to say x times dv dx, which is x cos x, plus phi times du dx, which is going to be sine x times, what's it, 1?
Yeah.
When you differentiate x, you get 1, and grand. Now, this is where we're at now with this, okay? And we all know this equals to y dx. We're going to do what we did last time, except I'm going to speed it up a step. We already know we're going to do them singly, aren't we? So it's going to be integral of the y equals integral of x cos x dx plus the integral of sine x dx. What's the target of the question? What's the target of the question, lads? Yeah, that's it there, isn't it? What happens when you integrate the y, Mr. Brown? What happens when you integrate 1 to y? Exactly. Bring this over to your side. Minus the integral of sine x dx. What is the integral of sine x? Does anybody know? So it's minus cos x then, isn't it? Great. Plus c equals the integral of x cos x dx. Now put that in. What is y at the start of the question? X sine x plus cos x plus c is the answer of your question. They actually sort of become easy now. Alright.